Lesson 3-6 is on proportional and non-proportional relationships. So we'll discuss more about the proportional versus non-proportional part in the next lesson. For today, you're focusing on if things are linear, which is what this chapter is about, then it has a constant rate of change. This means the same thing as it has a common difference. In other words, your arithmetic relationships are linear. And you know some important things about arithmetic relationships, such as a sub n equals a sub 1 plus n minus 1 times d. So here is our first example. Hours, 1, 2, 3, 4. Miles, 50, 100, 150, 200. So the first thing in this lesson that you need to be able to do is to graph these ordered pairs and pick an appropriate scale. So please do that. So I counted by ones along the bottom and 50s up the left, and I have my ordered pairs properly plotted. Looking at this, it looks linear. So if we think about our table, we have a 1, 2, 3, 4. That looks like they could be n values. Are we going up by a constant number every time? 50 to 100 to 150 to 200? I would say yes. Our common difference is 50. We are adding 50 every time. Since you know the common difference, you can write an equation. A sub n equals a sub 1 plus n minus 1 times the common difference. So a sub n equals 50 plus 50n minus 50. A sub n equals, the 50s cancel, 50n. Since you know this equation, maybe we want to make it more applicable to the problem. So the n values are actually hours, and the a sub n values are actually miles. So we could write this as m equals 50h. Or if you want to stick with x's and y's, you could write this as y equals 50x. All three of these equations are appropriate. Pick your favorite equation, and please predict how far you would drive in 8 hours. So to figure out how far you drive in 8 hours, all you have to do is plug in 8. So miles equals 50 times 8, which is 400. So we can try this again. If you were to turn to page 198, you'd find problem 1. We have goals plus donations. So please use this information to draw a graph. So I picked a nice scale. I'm using ones on the bottom and 75s on the side. So it basically looks like the same graph as before, and it still looks linear. Since it looks linear, we just need to find the common difference. And I hope you recognize that the common difference is 75. So a sub n equals a sub 1, the first number in the list, plus n minus 1 times your common difference, 75 plus 75n minus 75. A sub n equals 75n. And again, you could make it slightly more matchy to the letters. Instead of using n's, we could use g's. Instead of using a sub n, we could use d. Then donations would equal 75 per goal. And again, if you wanted to stick with x and y's, that would also be fine. Now that you have an equation, your job is to figure out how much money would be made for 12 goals. How much money would be made in 12 goals? So you would just plug in the 12, and I hope that you get $900. So we have one more example of this from page 199, problem 2a. Here's a table with x's and y's. So one more time, the first step is to graph it. So the first question asked is it linear? Looks linear. Your x's are 1, 2, 3, and 4, so those are just the number of terms in the list. So your list is 3, 2, 1, 0, which means you should be able to find the common difference. And this common difference is -1. You are subtracting 1 every time. So a sub n equals a sub 1 plus n minus 1 times d. A sub n equals your first term plus n minus 1 times your common difference. So 3 plus -n plus 1. So a sub n equals -n plus 4. So you should also be able to use this if I were to give you a graph like problem 2b on that same page. So let's look at problem 2b. I'm going to redraw it for you kind of fast. So they give you the entire line. I counted wrong. That's why it's not working. Whoops. There we go. They give you the entire line. It looks like this. So based upon what we have been doing, we need to know the first number, which is here. So that's this ordered pair. And the second number. And we'll assume it keeps working. So your difference is 2. A sub n equals a sub 1 plus n minus 1 times d. A sub n equals -2 plus n minus 1 times 2. Distribute properly. A sub n equals 2n minus 4.